In this video, we're gonna go through some of the instructions for your activity, and I'll give some examples as well and some extra notes that you may find useful. So the idea of this activity is just to go through and review a lot of what you learned in the last unit, and now you're gonna expand on that, relate it to logs, and also practice what you just learned in your lesson for the logarithms. Okay, so for the warm-up, we are looking at number 1 here. Select all of the following that are equivalent to, it's a little hard to see maybe, but this is 125 to the 4/3 power. So you're just going to go through and choose from these letters. You would want to probably work it out. You can do some scratch work over here and see how that goes. But for example, I would do this one. I know that it would be 125 to the 4th to the 1/3. I could split it apart like that, because when I do apply my power rule for exponents, I would get 125 to the 4/3. And then if I manipulate this and write 1/3 as a cube root, this is really what I'm going to be getting. Okay. I could also, that one would be this C, actually. If you manipulate it a little differently and split that up more like, I'll just leave that there. If you split it up like 125 to the 1/3 to the 4th, then you would have a different approach. I don't want to give them all away, but that one is there as well. So there should be 4 letters circled. Okay, and you can just do your scratch work right on there. Now remember, if you're writing on your own paper, please use the same positioning, so when I go to grade it, it's just more consistent, and I can see and find everything, and it makes it more efficient. Okay, now the next one over here, number 2, we have if 2 to the x equals 64, 4 to the y equals 64, and 8 to the z equals 64, then the values of x, y, and z are, so you're just going to choose from one of these. So you have to kind of play around with those and figure out what they are, and then choose the right letter. So one thing to help you with that, I'll just put a reminder of a law. If u to the x equals u to the y, then x equals y. So we want to take, I'll do this one here, 2 to the x equals 64. We want to take this number, 64, and write it as a base of 2. So 2 to the what would be 64. So you can figure that out maybe by manipulating 64. You could break it down if you want. You might be familiar enough with that one to know for sure. But if you think about it, 2 cubed is 8, right? 8 times 8 is 64. So 2 to the 6, it would make sense, would be 64. So then for this one, we know x would equal 6. So you'd have to find one down here with a 6, but then you also have to look at what the other 2 want as well. And then you can look at these questions. What is interesting about each of these equations? Can you think of any other instances where this may occur concerning exponents? So kind of think about the manipulations I just did and relate that to the questions. Just do your best with that. I will post the solutions to this after the 3-day grace is up so that you can see them, but you can also ask me questions too. And the grading will be like, I want to see effort. You may not get the full points if you aren't accurate on all of them, but if you at least have something down where you're showing your work, you're going in the right direction, you'll get credit for that. So I would recommend not just circling, random letters and guessing. You want to show some work down based on the lesson. It would be very similar to what you did in your lesson. Okay, so for 3 and 4, let's take a quick look at those. And I also want to mention too, if you want to pause the video and do these as I'm working, like you could have gone back and paused and done 1 and 2 completely, or you can just kind of peruse through the video from start to finish, get any tips you need and do it, or you can just dive in and try everything and then watch the video after and correct. But it might be good to know if you're kind of on the right track. That's why I'm making this guided video, because in a class I would kind of be doing it a little and then having you do a lot kind of thing, and you'd ask questions. So ask me questions, email me, or preferably even just write in the comments of this assignment so I know what it's attached to. If you just do a separate email, make sure you say what you specifically need. So for number 3 here, which of the following statements is true about the 2 functions? So you're going to read through these, and I would use process of elimination. And you probably at this point can eyeball these and kind of know which one it is, but then justify your answer. And remember, we can do a composition type thing to find out certain qualities. You could also probably eyeball if they're opposites, but just show out the math that you're using. So there'll be one of these, that just one that is true, and then justify that answer here. Number 4, select all of the following that are equivalent to 10 to the negative 2. I think that is probably pretty familiar to you at this point, so I'm not going to go through that, but there'll be 3 of them there for you. Little hint. So the next page here is guess my exponent. I do want to go back here for just a second and write a tip just in case you're forgetting something. But if we have x to the negative n equals 1 over x to the n, so that will be useful for you. 1 over x to the negative n equals x to the n, and we just covered exponents, so I'm sure you are pretty familiar with that, but just to have it there in case you need it. Now we're looking at guess my exponent, and on this one you are going to do the same type of thing that I did earlier. So you're going to take this number, so we have 10 to the x equals 1,000. So just to give you a little example, this one you probably could just do in your head, but I have the x equals there for you, so you maybe would just put your work underneath here. So 10 to the x, and 1,000 could be written as 10 cubed. That's why it's really important to know all your exponents really well and like to go back and forth with them. So we really zeroed in on that on the exponent review. So if you're struggling with that still, you might want to go back through that My Open Math and look at it and get some more practice with that. So now we can clearly see here that x would be 3 based on the law that we used before, that if we have the same base, the exponents would be equal if they are in fact equal. So you're going to do that all along. There's a couple of them that are a little trickier. So I'm looking over here at this one. 1 over 81 all raised to the t equals 9. So just to show out the work on that, I mean, of course, pause and try it on your own. As is with any of these, you can start filling it in. Just pause where you want to pause. So the first thing I do for this one is write 1 over 81 as 1 over 3 to the 4th power, and then that's raised to the t. And so that equals, I'm going to get everything down to its lowest prime base. So 3 squared, I'm going to write 9 as 3 squared. And then I could write this 1 over 3 to the 4th as 3 to the negative 4, and then to the t, right? So then I would have 3 to the negative 4t equals 3 squared. And so now I have, let me just draw a little arrow there. I would have to solve this out. You could do this in your head, I'm sure, but just write it out at first, especially if you're just a little unsure and you need to look at it. It's better just to have it there just in case. So I would have negative 4t equals 2, divide both sides by negative 4, and I would get negative 1/2. And I'm writing it out just, because I'm trying to show you an example. But again, this part, that I don't really consider that having to show a solution. So I hope that helps you get started on that. Let me know if you have any questions along the way. And again, if you just want to get this done now, just pause the video, fill it in, and as you're doing it, you can maybe have your email open or the comments open of the assignment and just be typing in questions if you're stuck on stuff. Try to go full circle before you send it, because you might make some discoveries on the way. But I want to make sure if you're stuck on something, I see it. And again, I check email more throughout the day rather than the night. So this part is about going from exponential form to logarithmic form, and just knowing that these actually are equivalent values. So these are equivalent things to say. So this means this goes either direction, so if and only if. So one thing that you learned there was just plugging in letters for the kind of like the format or the formula or whatever. But I want to use words here. I know I talked about that in the video as well. But here, just focus on the words, and then it's easier. If you know what the things are, it doesn't really matter if someone's calling it A, B, C, M, N, whatever. You know what it represents, and so it's a lot easier to remember. So this number here is the base when it's in exponential form. So 2, it's a base of 2 raised up to the 5th power. So that's my exponent. The result I get is 32. Now we have log form here, and this is how the same thing would read there. We would have log base 2 of 32 is 5. Okay, so the exponent now up here, the power is now what it's equal to. And you could have it on, kind of either side. I could have written this as, let me just write below here. I could have written it as 5 equals log base 2 of 32, that direction. That's fine, because that's an equivalency. So however you, kind of like to do that. So for this example, we have it given in exponential form. 3 to the 4th equals 81. So the first thing I'm going to do is write log. My base is 3. So log base 3 of whatever the result is over here. 81. And that equals the exponent. Okay. And if you were to use a calculator that had different bases, or use the change of base property that we'll learn later, you would get the same answers. They would be equivalent values. So now we're going to go the other direction here and look at this one. Log base 4 of 1/16 equals -2. So first thing we need to do is kind of think about like how that would present. What is my base? So I'm going to write that down first. So that would be 4. And then my exponent is the -2. And then my result is 1/16. And this is usually how we want to go, is given the log, put it in an exponent form so that we can figure out if there's some part missing, then we can find that value. So that's kind of what we're leading to. But you can tell from this, we could write the 4 as, well, actually, we don't even need to do that. We just know that we could write this as 1/4 squared, which would in fact equal 1/16. So I'll leave these other ones for you to do. I do want you to try to answer these questions and see if you can come up with a rule see if you can do it without referencing your notes. I gave you kind of lots of hints in there of what I call things. You can use the words and just put it in your own words. You can look up the definitions as well. But remember, if you're using letters, you could really replace any letter. Like I could say, if, let's just say D equals N to the, V, then I would do, that would be equal to log, and then what would my base be? Would be N, and then my results would be D, and then it equals my exponent. Okay, so see how when you just using letters, there's some standardization with it, but it gets a little confusing. And I just know there's all different kinds of, depending on the publisher, depending on the worksheet you may find, or some kind of list of, like I give you a log property sheet, a couple of different ones, and they may have different letters. But if you just think about what I was talking about earlier, and what things are called using their names might help you, and then relate those to the standard letters. And just do your best with that. Here we have some practice problems for you to work on. And for all of these, you are going to be, let me just double check. You're just going to be finding what the value is. So of the missing piece, and see how there's just different letters in different spots, and they're called different things. So I'll do this first one here. I'll do a couple. So log base 2 of 16 equals x, and we need to find x. So we're just going to do a little bit of rearranging here. If we can put it in exponent form, 2 to the x equals 16, then it makes it much easier to work with. I don't need to use a calculator. I don't need to use the base change anything. I can just quickly do that. 2 to the x equals 2 to the 4th. So therefore x equals 4. If I have something missing in a different spot, just like let me do one that's a little bit trickier maybe. Like example 3, if I have the base I'm trying to find, so I would write that as my base to my exponent is 3 equals my result is 216. And now I just need to manipulate 216 and figure out what base that is. So a cubed equals 6 cubed. And if you didn't know that off the bat, you could do a little prime factor tree and kind of just go through that process. As this could even break down further if you wanted to and figure it out from there. But I would have then my bases would be forced to be equal if my exponents were equal. So then a would have to equal 6. Okay, but again, you could play around with those to figure it out. So I just wrote a little refresher up here if you want to look at it. If you're good with that, then skip it. But I just did the prime factorization of 216. I started dividing in by 2 and breaking down numbers till I get all primes here. And then I write my primes, 2 cubed times 3 cubed. So I can actually kind of reverse my product power and go power to product, I guess. I don't know. Write that in parentheses there. 2 times 3 cubed would be 6 cubed, and that's how I got this. If I didn't recognize right off the bat. So a little tip there, a little refresher. The next thing you have is a graphing activity. And you've done a lot with graphing. So you can graph the line h of x equals x. So that's just the same as y equals x. And that would be if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2. If x is negative 3, y is negative 3. I'm just, saying all those equivalencies there, and you could dash that in. And then you're going to graph the function 2 to the x, which you've done before. So I want to start with a negative 2 and end up with a positive 2. So you can go ahead and do that. I'm sure you know how to graph that by now. You can check it in Desmos, but do it out by hand. Again, knowing those quick sketches, it just helps you to learn it better than always looking at a computerized graph. And the next part is to graph the log base 2 of x function. And I've just done a couple examples already out on the paper for you. So you can make sure you're on the right track. And to find your values here, you're going to have to use the skills we just learned of exchanging form and finding the value. And you can notice here, look how those change around, right? So with every inverse, we know for all inverses, we know that if AB is on one graph, then BA is on inverse, right? Is on the initial graph. So that's why we have those switched up. So just go ahead and sketch those in kind of quickly and take a look at how they present on that one. And then lastly, there's just a little interpretive thing to do. So what you want to do is show that these two functions are inverses of one another. So I wrote some ideas of how you could show that. So the graph is already there for you. You could kind of do what happened above and show in relation to the y equals x line. You could show some points kind of related to what I just wrote there. And then also down here for algebraically, you could find each inverse and show that they're how they relate to one another. And then you could, another method, you don't have to do both of these, but you could do either or. Find f of g of x and you should get x, and likewise g of f of x, you should get x. So a couple of different options. This is like a one or the other, right? So you don't have to do both. You just have a choice there. Just you have to show it by graphing and by algebraically, but only pick one of the ideas, one of the methods for A and one of the methods for B that I gave as hints. So I hope that helped. This gives you a really good review. I know a lot of students tend to shy away from logs and think they're going to be really scary, but I think they're super fun. They're like a puzzle, and you're just kind of going by the rules, and that is there's not too much to interpret in these sections. When we get into the word problems and stuff, that's where it gets a little trickier, but you can do it just fine because you're learning how to manipulate all these things with your skills. So hopefully that helps and that you're getting a comfort level with that. I would work on memorizing the properties, even though you don't have stuff that's proctored. Eventually you will, maybe next term. And sometimes not having proctoring but you're timed, you don't necessarily have everything all set up and have studied, and you're reaching for stuff during your test, and that's not a good plan. You want to make sure that you memorize these things and have a sheet made out, a note card, kind of that idea, that as if you were in a class, so that you can start to internalize those things, and that'll make you way more efficient in doing all your work from here on in. So have a great day. Let me know if you have any questions.